consider a function f of x is equal to sin x. F of x is nothing but y, y is equal to sin x. In the interval x belongs to closed interval 0 comma pi. 0 comma pi means first quadrant and second quadrant, right? So A can be sine 0 degree. I'll take few standard angles: sine 30, sine 45, sine 60, sine 90, sine 120, 135, 150 and 180 degrees. Sine 0 degree is 0 and the set B is, since it is between 0 to pi, first and second quadrant, observe the graph. From first and second quadrant means from maximum is 1, minimum is 0. Suppose if it is third and fourth quadrant means, so between 0 and minus 1. Okay, so 0 to 1. 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. Sine 0 degree is 0. Sine 30 degree is 1 by 2. Sine 30 degree is 1 by 2. Sine 45 degree is 1 by root 2. Sine 60 degree, which is root 3 by 2. Sine 60 degree. Sine 90 degree means 1. Sine 90 degree is 1. 120 degree. Sine 120 can be written. 120 can be written as 180 minus 60. So sine of 180 minus 60 means second quadrant. Sine 60 degree, which is root 3 by 2. Root 3 by 2. See, if I don't take 120, 135, 150, 150, then this becomes a 1 function. Since we have taken from 0 to pi, I select these values also. Now look at this. So two different elements take the same value. Sine 60 degree and sine 120 degree. Both are root 3 by 2. It is not 1. 135 can be written as 180 minus 45. 180 minus 45 means sine 45 degree. Sine 135 degree is the same as sine 45 degree. Again, the image is not unique. Uniqueness fails. 150 degree is 180 minus 30 degree. So that is nothing but sine 30 degree is 1 by 2. Then sine 180 degree. Sine 0 degree is 0. Sine 180 degree is also 0. Sine 180 degree is also 0. So clearly, f is a function from A to B. F is a function from A to B. Right? Every element of the set A have a unique image. Isn't it? So is this 1 function? Is this 1 function? So clearly it is not 1. Not 1 function. So, and obviously all the trigonometry functions are onto functions, periodic functions, So it is the complete codomain is range. That's why it is onto function. Onto function. Onto function, but not 1. F is a function from A to B. Since it is not 1, it cannot be bijective. Since it is not bijective, inverse of the function does not exist. That means, so f from A to B means the function from B to A does not exist. So not invertible. To make it as invertible, what we need to do? So we need to eliminate these values. That means we need to restrict the domain and the range so that the function becomes 1 and hence becomes bijective, which implies invertible function. Okay, let us see. From the above example, we observe that in the closed interval 0, pi, sine function is not 1, but it is onto. Hence, it is not invertible. not invertible. That means inverse of the function does not exist, not invertible inverse function. In general, all the trigonometric functions are periodic functions. Hence, they are not one functions. All the trigonometry functions are periodic functions, sine and cos, say period with 2 pi, period of 2 pi. So, they are not one functions. Therefore, their inverses does not exist. Inverses does not exist. But by restricting the particular domain and range of the trigonometric function, suitably we can define the inverse trigonometric function. By restricting the domain and range, they become one function. They become one function. Hence, we can find their inverses. We can find their inverses. For that, let us consider the graph of the sine function. X-axis, negative x-axis, y-axis and the negative y-axis. So, maximum value of y plus 1 and the minimum is minus 1. Say this is pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, 3 pi and so on. Similarly, here minus pi by 2, minus pi, minus 3 pi by 2 and so on. Sine pi by 2 is plus 1, sine 0 is 0, sine pi by 2 plus 1, sine 180 degree is 0, sine 270 degree plus 1, sine 360 degree 0, sine 5 pi by 2 plus 1, sine 3 pi 0. Similarly, sine of minus 90 degree, which is minus 1, sine of minus pi, which is 0, sine minus 3 pi by 2 plus 1. So, you just join these values in a smooth hand. Like this, it goes on. Okay, 0 to 2 pi. This completes one cycle. The period of sine or cos 2 pi. One complete cycle. The period or cycle we call it as. This is the maximum value plus 1. Period we call it as from here to here, period. Even this minus 1. So now, if I take 0 to pi, if I consider 0 to pi, 0 to pi, see, 0 to pi by 2, this is the first quadrant. 0 to pi by 2, first quadrant. Pi by 2 to pi, that is the second quadrant actually. See, from 0 to pi, it takes a maximum of 1. Pi to 3 pi by 2, third quadrant. 3 pi by 2 to 2 pi, fourth quadrant. From 270 degree to 360 degree. So, maximum here is minus 1 we have. Okay. So, now, from 0 to pi by 2 if we take, So it is an increasing function from 0 to pi by 2 in the first quadrant. In the second quadrant, pi by 2 to 3 pi by 2, it is decreasing. Pi by 2 to 3 pi by 2, it is decreasing. If we take from 0 to pi, from 0 to pi, it is both increasing and decreasing. The sine function from 0 to pi, it is increasing, whereas this is decreasing. Both increasing and decreasing function. That's why it cannot be one function. Let me explain. Say, this is 0, this is 1. This is 1 by 2. 1 by 2. 1 by 2. See this? So this is actually 30 degree, pi by 6. Or 30 degree. See this? Increasing from 0 to pi by 2. Pi by 2 to pi, it is decreasing. Okay? So, from 0 to pi ಏನು value ತಗೊಳುತ್ತೋ, pi by 2 to pi ಕೂಡ same value ನೇ ತಗೊಳುತ್ತೆ. I am taking an example. Sine 30 degree, 1 by 2. See this? Here also, this value is 150 degree, 5 pi by 6. 150 degree. Clearly, both are, see, 150 degree or else even 30 degree. Both takes the value 1 by 2 only. I mean, f of pi by 6 is equal to f of 5 pi by 6. Both are equal to 1 by 2 only. Sine 30 degree is equal to sine 150 degree. This is a given function. Y is equal to sine x, sine function between 0 to pi. So sine 30 degree, sine 150 degree, both are equal to 1 by 2. See this? F of x1 equals f of x2, but x1 and x2 are not equal. 30 degree ಬೇರೆ 150 degree ನೇ ಬೇರೆ. Even though f of x1 equals f of x2, x1 and x2 are not equal. So clearly, mathematically it is not 1 1. Graphically here, so both these values are 1 by 2. Sine 30 degree and sine 150 degree, both are 1 by 2. That's why it is not 1 1 1. So if a function is both increasing and decreasing function, we cannot expect that to be a 1 1 function. Okay, so it cannot be 1 1 if it is both increasing and decreasing. So we need, if it is to be 1 1 function, we need to take only increasing function or only decreasing function. So only increasing function means which interval we can take? Which interval we can take? Only increasing means minus pi by 2 to plus pi by 2 if I take. Minus pi by 2 to plus pi by 2. This. Observe this. See this? So this is only increasing from minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. It is only increasing function. So whatever the value you take for x, you get a different values for y. That's why it becomes a 1 1 function. Or else from pi by 2 to 3 pi by 2, we can take this interval also, that is pi by 2 to 3 pi by 2. Pi by 2 to 3 pi by 2. See, this is also decreasing. This is a decreasing function from here to here. This interval. Okay? This interval. Pi by 2 to 3 pi by 2 only decreasing. Again, from 3 pi by 2, from here to 5 pi by 2. 3 pi by 2 to 5 pi by 2, it is only increasing. 3 pi by 2 to 5 pi by 2, it is only increasing function. In this case also it is again 5 pi by 2 to 7 pi by 2 and so on. From this side minus pi by 2 to minus 3 pi by 2 to minus pi by 2. We can take minus 3 pi by 2 and minus pi by 2. In this interval, see this, the function is only decreasing. I repeat, minus pi by 2 to this interval, minus 3 pi by 2 to minus pi by 2, only decreasing. Minus pi by 2 to plus pi by 2, only increasing. Pi by 2 to 3 pi by 2, only decreasing. Or else 3 pi by 2 to 5 pi by 2, only increasing. So, in these values, observe this, this is the least value. Numerically, least value. So, that is, numerically least value is this is considered as in and around origin. In and around origin. Numerically, least value is called principal value branch. Principal value branch. Minus pi by 2 to plus pi by 2. Here, both 1, 1 and on to. Both 1, 1 and on to. Okay. Even in this interval, both 1, 1 and on to. Here also, because only decreasing, here also both 1, 1 and on to. Here also both 1, 1 and on to. So, you can take all these intervals to be 1, 1. So, of these, numerically least value, minus pi by 2 to plus pi by 2. So, that is in and around origin is considered as the principal value branch. So, in this interval, you can make the function, sine function as 1, 1. So that all the trigonometric functions are onto function, as all the trigonometric functions are periodic functions. So, here both 1, 1 and onto means bijective. Once it is bijective, inverse of the function exists. That means x is equal to sin x is equal to y means sin x is equal to y means x is equal to sin inverse y we can write. X equals sin inverse y in this interval. So that's why minus pi by 2 to plus pi by 2 is considered as the principal value branch. In that the sine function is both 1, 1 and onto, hence the inverse of the sine function exists. So just now I have explained, from the graph we observe in the interval 0, pi, the sine function is both increasing and decreasing. So hence it is not 1, 1 function. So we restrict the domain and range. We can make the sine function as 1, 1 in this interval. In this interval, the least value is considered as the principal value branch. Hence, the inverse of the sine function can be found if we restrict the value of x between minus pi by 2 to plus pi by 2, which is known as principal value branch, PVB, principal value branch. Let us see the graph of the inverse trigonometric functions now. Let us discuss the graphs of inverse trigonometric function. At that, first one, inverse sine function. Definition: if y is equal to sin x with x greater or equal to minus pi by 2 and less or equal to pi by 2, and y greater or equal to minus 1 and less or equal to plus 1, then x is equal to sine inverse y, x is equal to sine inverse y exists and is called inverse sine function or arc sine function. Inverse sine function or arc sine function. See the graph. So 0, pi by 2, this is minus pi by 2, maximum 1, minimum minus 1. This point is 0, 1, this is 0, minus 1. So you know the graph of the sine function. So just like this, okay. This is the graph of the sine function. So it is only increasing function. Look at this. Only increasing function between minus pi by 2 to plus pi by 2. So different values of x takes different y values. For different values of x, we get different y value. So that means it becomes 1 function. Okay, so inverse of the sine, this is the graph of y is equal to sine x. You just interchange x axis and y axis. On x axis minus pi by 2 comma plus pi by 2. Here pi by 2 comma minus pi by 2 on y axis. On y axis 1 comma minus 1 ittu. Illi x axis mele baratte. Look at this. 1 comma 0, 0 comma pi by 2 means here just like this. Yeah, see, this is the graph of the inverse sine function, sine inverse x. It goes on like this. Okay, so on y axis, by just interchanging x and y coordinate, we get the inverse of sine function. Y is equal to sine inverse x, graph of sine inverse x. Okay, again this is also only increasing function between minus pi by 2 and plus pi by 2. Second one, inverse cosine function definition. If y is equal to cos x with x greater or equal to 0 and less than or equal to pi, and y greater or equal to minus 1 less or equal to 1, then x is equal to cos inverse y, x equals cos inverse y exists and is called inverse cosine function or arc, arc cosine function. Let us see the graph of this. So 0 pi by 2 pi, okay, 0 comma 1, 0 comma minus 1. So this is the point here, just like this. It is only decreasing function, you can note it, isn't it, between 0 to pi. For cosine function, if you take minus pi by 2 to plus pi by 2, minus pi by 2 to plus pi by 2, both increasing and decreasing. In such case, it cannot be 1, hence it is not bijective. Hence, inverse of this cosine function does not exist if you take minus pi by 2 to plus pi by 2. That's why you need to take from 0 to pi, 0 pi by 2 pi. Y is equal to cos x, graph of cosine function. Now, y is equal to cos inverse x. So as I said, so 0 pi by 2 pi should go to y axis. So 0 comma 1, 0 comma minus 1 here on the x axis. So this is pi by 2, 0 pi by 2 pi. The graph should be something like this. Okay, cos 0, cos pi by 2 here, okay, this one. Y is equal to cos inverse x. So graph of cos inverse x. Third one, inverse tangent function. Inverse tangent function. If y is equal to tan x with open interval, not closed interval, x greater than minus pi by 2 and x less than pi by 2, whereas y is a real number, that is minus infinity to plus infinity, open interval, y greater than minus infinity and y less than plus infinity, then x is equal to tan inverse, x equals tan inverse y exists and is called inverse tangent function or arc cotangent function. Let us see the graph. See, minus pi by 2, this is plus pi by 2. Minus pi by 2 and plus pi by 2. X-axis and the y-axis. Here also, this is minus pi by 2. As we know, y takes the value plus infinity and minus infinity. Y takes the value like this. It should be like this. Yeah. It won't touch x is equal to pi by 2. Innane touch agutte ankantivi, but touch agalla. So touches somewhere at infinity. That is what we call as asymptote. Okay, 0, tan 0, 0. Tan pi by 2 is plus infinity. Tan minus pi by 2 is minus infinity. No? This is the graph of y is equal to tan x. Y is equal to tan x. Correct? So now, graph of tan inverse x. This is pi by 2. Pi by 2. And minus pi by 2. This is minus pi by 2. Okay. This is the origin. Pi by 2 minus pi by 2. The graph should be like this. Touch agbardu illi. So this is the graph of y is equal to tan inverse x. Understood? Fourth one, inverse cotangent function. Definition: if y equals cot x with x belongs to open interval 0 comma pi, whereas cos x is closed interval 0 comma pi. Please note it. That is x greater than 0 and x less than pi, whereas y greater than minus infinity and less than plus infinity, then x is equal to cot inverse y exists and is called inverse cotangent function or arc cotangent function. Let us see the graph. X-axis and the y-axis. 0, this is pi by 2, this is pi, you know, this is pi. So the graph should be something like this. ಹೀಗೆ pi by pi ನಲ್ಲಿ ಟಚ್ ಆಗಬಾರ್ದು, ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ, 0 ನಲ್ಲಿ ಪ್ಲಸ್ ಇನ್ಫಿನಿಟಿ. ಸೊ pi by 2 ಮೂಲಕ ಪಾಸ್ ಆಗುತ್ತೆ. y is equal to cot x, whereas y equals cot inverse x. 0 pi by 2 pi. ಇಲ್ಲಿ x axis ಮೇಲೆ ಇದ್ದು y axis ಮೇಲೆ ಹೋಗುತ್ತೆ. ಓಕೆ, ಸೊ ಇನ್ವರ್ಸ್ ಫಂಕ್ಷನ್ಸ್ ನ ಗ್ರಾಫ್ ಕ್ಯಾನ್ ಬಿ ಒಬ್ಟೈನ್ಡ್ ಬೈ ಗ್ರಾಫ್ ಆಫ್ ಇನ್ವರ್ಸ್ ಫಂಕ್ಷನ್ ಕ್ಯಾನ್ ಬಿ ಒಬ್ಟೈನ್ಡ್ ಬೈ ಸ್ವಾಪಿಂಗ್ x and y values. Okay, so this is pi by 2, you know, this is pi by 2. The graph should be something like this. ಹೀಗೆ this is graph of cot inverse x. Y is equal to cot inverse x. Fifth one, inverse secant function. If y is equal to secant x with x greater or equal to 0, less or equal to pi, where x not equal to pi by 2. Whereas in case of cos inverse, closed interval 0 comma pi, here x should not be pi by 2, not defined, you know, and y less or equal to minus 1 or y greater or equal to 1, then x is called secant inverse y. X equals secant inverse y exists and is called inverse secant function or arc secant function. Let us see the graph. X-axis and the y-axis. So 0, pi by 2, pi. This is pi by 2. And on y-axis 1 to minus 1. So here the graph is like this. Cosine function is this, it should be inverse of that mirror image. And minus 1 here, pi from here like this. There is no graph between minus 1 and plus 1. See here, y should be greater than 1. Y greater than 1. Y should be less than minus 1. See the graph? There is no graph here. Here, this is minus 1. So like this. So y greater than minus 1. Sorry, y less than minus 1 and y greater than plus 1. Here is the graph. Okay. And for the inverse function, so 0, this is pi by 2, this is pi. So 1 and minus 1. You need to change x values and the y values, x value 0, pi by 2, pi, 1 and minus 1. So it is on x-axis. So the values on x-axis becomes the values on y-axis. See the graph? Yeah. 1 to pi by 2. So whereas here pi by 2, it won't touch pi by 2. Pi, this is pi. This is the graph. See, the graph does not meet pi by 2. That's why x should not be pi by 2. X should not be pi by 2. See here, x should not be pi by 2. So from pi to this graph, so here no graph between this region. Okay, y is equal to secant inverse x. Sixth one, inverse cosecant function. If y is equal to cosecant x with x greater or equal to minus pi by 2 and x less or equal to plus pi by 2, where x should not be 0. X won't take 0. There, in case of secant, x won't take pi by 2. And y less or equal to minus 1 and y greater or equal to plus 1. Then x is equal to cosecant inverse y exists and is called inverse cosecant function or arc cosecant function. X-axis minus pi by 2, 0, pi by 2. So minus pi by 2 to plus pi by 2. And on y-axis plus 1 and minus 1, here it won't take pi by 2. Something like this. Here. I mean it takes pi by 2 actually. It won't meet pi 0. Okay. Here also including pi by 2 minus pi by 2 but excluding 0, right? X value this is 0. Illellu illa nodi 0 nalli meet madodilla x graph. So this is plus infinity. So that means y greater than the values of y. Observe, y greater than plus 1 and y less than minus 1. See here, in this interval between minus 1 and plus 1, we don't have any graph. Instead of writing y less or equal to minus 1 or y greater or equal to 1, you can write minus infinity comma 1 closed interval union 1 to infinity, or set of real numbers except minus 1 comma plus 1 also you can write. See, this is y equals cosecant inverse x. Let us see the graph of cosecant inverse. So the values on x-axis becomes y-axis. Minus pi by 2, 0, pi by 2. See, pi by 2, 0. This is minus pi by 2. This is 1 and minus 1. See this? ಹೀಗೆ and here plus pi by 2 1 ಪ್ರಾರಂಭ ಆಗುತ್ತೆ. It won't meet x-axis here. X is equal to 0 ತಗೊಳ್ಳೋದಿಲ್ಲ ಇಲ್ಲಿ ನೋಡಿ ಗೊತ್ತಾಗುತ್ತೆ ನಿಮಗೆ. X is equal to 0 won't meet, the curve won't meet at 0. X equals 0 ನಲ್ಲೆಲ್ಲೂ ಮೀಟ್ ಮಾಡಲ್ಲ ನೋಡಿ. So this is the graph of cosecant inverse x. Okay. So these are the graphs of the inverse trigonometric functions. Okay, so the interval is range and domain is very important. As per the examination is concerned, the interval, I'll give the table now, you just remember that table, but the graphs probably they won't ask. Okay, so only in first main we need those interval, which is very important throughout the topic.